Let's remind ourselves how to name alkenes and alkynes. So the first step is we want to name the parent compound, and that depends on how many carbons are in the longest continuous chain with the double or triple bond. So there's 6 carbons in the longest chain that has a double or triple bond, then it would be a hexene or a hexyne. We know this what the suffix will be depending on whether it is a double or triple bond. Double bonds have a suffix of "ine" and triple bonds have a suffix of "ine." If there's more than one double or triple bond, we indicate that with different numbers, the lowest possible numbers where those double or triple bonds are, and then the suffix also indicates how many double or triple bonds there are. If there's 2 double bonds, then the suffix will be diene. If there's 2 triple bonds, the suffix will be diene. If there's 3 triple bonds, the suffix will be triene. So it is really important when you are determining the longest carbon chain that you make sure that the double or triple bond is included in that chain if there are a lot of branching. When we number our carbons, we always give the double or triple bond the lowest possible number. So at the bottom here we have an example of a branched alkene, and even though the longest continuous carbon chain has more than 6 carbons, this has to be a hexene because we only count the longest chain that has the double bond in it. The double bond or the triple bond has priority when we're determining the longest carbon chain. So once we have determined the chain length and what the suffix is going to be, then we begin numbering the carbons so that the double or the triple bond gets the smallest possible number. Now sometimes, no matter which way you go, from left or from right or up or down, no matter which way you go, the alkene or alkyne will have the same number. If that's the case, you want to look for any branching and number it so that the branches get the smallest possible number. But we're not going to use the branches to determine our numbering if they're on opposite sides. So for example, this last example here, the methyl branch is on the opposite side of the triple bond. We have to number to give the triple bond the lowest possible number. And then this slide here gives you some examples of how to number, always giving the double or triple bond the lowest possible number, and if possible, branches low number, but the double or triple bond has the priority. If we're looking at alkenes, the double bond is always going to be the 1 and 2 carbon, and which carbon is 1 and which carbon is 2 matters if there's a branch. So we always want to give the branch the smallest possible number. So this graphic here has a methyl group, and we can number it so that the methyl group has a 5 or a 4 position. So we want to use the numbering system that gives the methyl the 4 position, the lower name. So then we're going to figure out what the whole name is. So we assign numbers to the branching substituents. We arrange any substituents alphabetically, use commas to separate numbers, hyphens to separate words from numbers, and indicate the position of the multiple bond by giving it the smallest possible number. So what I want you to do right now is go ahead and name these 3 alkyne, these 2 alkynes and this 1 alkene on the slide, and then when you're done we'll go over those names. So here we have 1 pentene. The 1 is the smallest possible number to assign that double bond. 2 hexyne, it's a triple bond, and 2 is the smallest possible number. And then 3 propyl 2 hexene. Here's also this example that we saw where the triple bond is on the opposite side of the branch, 7-methyl 2-octyne. And then here we have an example of what you do when there's 2 double bonds. So we find the longest continuous chain that has the double bonds, that has 4 carbons. So our root is bute. There are 2 double bonds, so our suffix is diene. There is a branch, so we number it so this branch gets the smallest possible number. So this is 2-ethyl 1,3 butadiene. And then here's the same example we saw earlier of the 4-methyl cyclohexene.